this is problem 3, chapter 5, number 39, and this gives you an idea of something that you can do with gases which you would not be able to do with liquids and solids in a stoichiometry problem. Nitroglycerin is an explosive used by the mining industry, detonates or decomposes according to the following equation. It's a balanced equation, and the volume occupied by the gases is what they want to know. And so you are starting with 10 grams of nitroglycerin, and you want to know the volume of all the gases, and notice that every product is a gas. And the volume is going to be measured at 145 atmospheres and 523 degrees Celsius. Well, we've got this 10 grams. We're going to have to start with a stoichiometry problem. And we'll be going from grams to moles. And this will be the nitroglycerin. And then we can convert to moles of gas. And then from there we will go out into PV equals nRT, and we'll be solving for volume. So we are going to lump all those gases together. They are not asking for any particular gas, and all the gases have the same properties as far as the amount of space and the pressure and so on that they're going to occupy. So we're going to start with our 10 grams, and this is C3H5N3O9. And actually what this looks like is 3 carbons, each attached to an O, and each O is attached to an NO2 group at that point. Well, that's the N, and it's an O, an O. And then the H's sit around here. So that's what nitroglycerin looks like. But we need the molar mass of that. We have 3 carbons at 12. We have 5 hydrogens at 1. We have 3 nitrogens at 14. And we have 9 oxygens at 16. So 3 times 12 is 36, 5 for that. 3 times 14 is 52. And 9 times 16, I'm going to check on that. It's 108. Whoa, let's clear that. 9 times 16 equals, 144. And when we add that all up, 10, 17, 8, 9, 13, and I'm getting 237. I hope that's right. So 237 grams per mole. And then there are 4 of the nitroglycerins. And we have a total of moles of gases. We've got 12 CO2s, 6 N2s, 10 H2s, and 1 oxygen. We don't want to forget that. And so that is 8, 9, that's 29. And we can lump all these together. You could not do that if they were liquids or if they were solids. You would need to use the molar masses and so on to get the answer. So we have our 10 grams. We're going to multiply that times 29. Divide by 237, and then divide by 4. And I get 0.31 moles of gas. This can then be dumped into the ideal gas law. PV equals nRT. My P is 1.45 atmospheres. I'm solving for V. N is 0.31. R is 0.0821 because I am in atmospheres. And T is 9 is 796. So I will be dividing both sides by 1.45 to get V. So I have, clear that, 0.31 times 0.0821 times 796 divided by 1.45, and I get 13.97, so I get about 14 liters. So that is about 10 grams, which might be a tablespoon of material, and the products of that are going to take up about half the amount of space of a beach ball. And that's part of the reason why these sort of compounds are able to just blow things apart, because these gases expand rapidly and at high temperatures.